Good.
Hi.
Fire, yeah, it's Friday, almost there. So I'm Brandon Stratton with the wireless team. So we're going to talk just quickly overview of wireless on campus, things that might help you guys as far as troubleshooting, know what's going on.
Thanks.
Yep, let's get started. All right, so currently right now we have 4 networks on campus called SSIDs. So when you open up your laptop, you'll see these 3. You technically see this one, but you won't see the name. So the difference between them is the UH Wireless is our guest network. Technically, anyone without KuberNet credentials, that's kind of who that's designed for. UH Secure is our kind of faculty, staff. Anyone with KuberNet credentials can use this one. Eduroam, we'll talk. I got another slide on it. We'll talk a little bit more what it is. It again uses the same credentials. It's for other institutions, anyone else that cooperates in the Eduroam program, and then UH Registered, which we'll talk more about. The percentages I put on here is current usage, basically. So as you can see, 85% of people on our network use UH Wireless. They're probably not all guests. So again, UH Wireless is nice because it's easy. You don't have to do any credentials. You just click on it and it works. So I think that's obviously the reason why most people use UH Wireless. All of these networks have the exact same capabilities. So if you ever hear someone say like, this one's faster than this one, it's not technically true. They're all designed the exact same way. They all operate the exact same way today. In the future, maybe we'll do something with guests, but at least right now they all have the same capabilities. So kind of go into each individual one. So this is Eduroam. So so edu as in education. So higher education are the only ones that can get into Eduroam right now. So these are all, this is kind of just a sample of all the places that participate in Eduroam. So what that means is, if you guys go to Australia, whatever this university is, or cluster of universities, you can log in with your KuberNet credentials to their Eduroam. So again, it broadcasts Eduroam just like it does here. You just walk up to their campus. If you have auto join on, it automatically connects. You're good to go. So that's really cool in places like Europe or other areas where you have to like pay for internet access, or it's a little harder to get to it. Literally just go to wherever your local college university is, and if they have Eduroam, then you have free internet. And all of these institutions can come on our campus and also use Eduroam. So weekly we can see a report of all the people that come on our campus. Most of it's Rice, most of it's local professors, students that maybe they're taking classes at both places. But then we also have, I would say that the second one after outside of Texas is probably Europe. So we have less people from the US, more people, European professors, students, whoever it is that come on campus. And the reason why we see this is because we can see their email, right? So the end of it, ours is uh.edu. So it's at least University of Houston or University of Hawaii, something UH, right? With theirs, typically you can tell where they're from based on that. So. And again, it's the same KuberNet credentials as UH Secure, so there's nothing different about it. Any questions on that?
Yeah, I actually do.
Yeah.
Is that a networking? I mean, how is that designed? Is it a tunneling protocol? I mean, what is it exactly?
Yeah. So basically, so whenever we authenticate to UH Secure or wherever it is using our KuberNet credentials, it goes against our Active Directory, right? So a big giant list of who can get on, what their credentials are.
Windows Enterprise, right?
What's that?
It's Windows Enterprise.
Here, yeah, we have Windows Active Directory.
Okay.
So what Educause does basically is whenever you connect to Eduroam here, it first checks our local directory, and if it says, look, I don't even know, again, if it's at kubernet.uh.edu locally, anything else, it goes out. So Eduroam basically has servers all across the world. So again, let's pretend ours is in Dallas. I don't know where our local server is. It points to that one in Dallas, and then Dallas has a record of all of the participating universities.
Oh, okay.
So at kubernet.uh.edu is in everything around the world. So let's say you're in Australia, it hits that server and goes, oh, I know where that at Kubernetes, it's actually
Okay.
back in Houston, points it there, hits our Active Directory and says yes or no.
And then it validates you. Okay.
Yeah. So same thing, anytime someone else comes from another campus, it hits whatever that regional server is and goes, oh yeah, I know where their directory is.
Awesome. Man, that's good. Okay.
Yeah.
Thank you.
So that's why from a security standpoint, we don't see any foreign credentials. People don't see our credentials. Literally, it just sends that request, and then all they get is a yes or no. Yes, they're authenticated. No, they're not authenticated. So there's some trusting in that, if you have some rogue campus that's just giving out credentials to anyone and everyone, now they can get into our network. But that's why on the, universities that are a little bit more concerned about that, you can limit access. So like you can connect to Eduroam but can't get to local switches or servers. I mean, you can basically limit
There's a
it to
firewall
whatever
or
you want
something.
to do.
Okay.
So that's why if you go to some of these other places, you will get internet. It'll be secured, right? So because you're using authentication, it's encrypted. So if someone's using just a Wireshark, they're not going to see what you're doing. But you may not have full access to their network, full capabilities, all that stuff.
Okay.
Yeah, so that's how it works.
Awesome.
And it's growing. So it started basically in Europe, and it's growing more and more in the U.S. And then also in Asia, it's growing quite a bit, and then you're seeing it some in Africa starting to grow.
That's awesome.
But it's based out of Europe, which is why there's so many universities in Europe that are doing it.
That's awesome. Thank you.
Yeah. So UH registered. So at one time, UH Wireless, we were talking about putting up a splash page. So splash page, you go to McDonald's, you connect, and it pops up a browser saying, don't be a bad guy, right? You say, accept. So at one time we were talking about doing that. The problem with those networks is printers and Xboxes, anything that doesn't have a web browser can't connect to a network that requires a splash page. So our workaround behind that basically was UH registered. So it was designed for printers, Xboxes, some IoT devices, Internet of Things, so like doorknobs, light bulbs, things like that. Any kind of device that doesn't have a splash page is designed to go on UH registered. Right now, because UH Wireless is completely open, there's no splash page, everyone basically just uses that. But in the future, if we end up doing something like that for UH Wireless, that's when we'll do UH registered. UH registered, even though so the process to register your device, so any student, faculty, staff that has access to Access UH can register it. So it just says register my Wi-Fi device, and you manually type in the MAC address and what type of device you have. So when I connect to it, it's still not encrypted. So someone with Wireshark will be able to see all of my traffic. But when I get through to that access point to the back end, it'll have a list of MAC addresses that can go through. And if you're not on the list, you don't connect. So that's why not anyone can connect to it. The other thing is, this is what they call a hidden network, which just means if you open up your laptop now, you'll see a network that says hidden or unnamed. That's what this is. So in order to connect to it, you have to type in so connect to network, UH registered, and then this will pop up. So you have to manually be able to connect to it. So in the dorms and stuff, and printers, we are seeing some people use this, but again, it's still pretty small just because UH Wireless is, you don't have to go through this process. The other thing I'll quickly say on that, whenever people register their MAC addresses, they literally are just reading it and manually typing it in. So if you're off by one letter, you put B instead of 8, it doesn't work, right? So it's got to be, when we first implemented this, a lot of our tickets that we're having, people like, oh, I registered it, and then you go check it and it's just one number off, right, or something like that. So if you get any tickets on these, just try to verify with them the MAC address. Okay, read it out loud. Okay, it's this rather than that, right, whatever it is. So I have this on here just because this is basically how we see the campus. So we've divided the campus into different categories. So categories 1 through 3, basically academic, residential, social spaces, administrative, outdoor. The reason why I say this is because currently right now we're 100% deployed, so 100% coverage and capacity on the wireless for academic, residential, and almost all social spaces. So social spaces being like study spaces, UC is in, so a lot of the UC is in the social spaces. Library is going to be some social, some academic. Administrative and down, we're probably like 75–80%. So that's basically what we're working on now, is continuing to keep this technology, the latest and greatest technology in academic spaces, and kind of cascade down, and then administratives to try to keep deploying more. So FAMUS, so a link, you can click on any building and you can see it categorizes each individual space. So that's why whenever tickets come in and we can kind of see what room people are complaining about, that helps us, because if someone says, hey, I have low signal and it's an academic space, we say, okay, there's maybe a device issue, something's going on, because we know all academic spaces are covered. If they're in administrative spaces, okay, maybe there actually is not enough signal. Maybe there's not an access point that's close enough to them. So that's why the rooms, room numbers, location, all that stuff is helpful. So wireless, they, just kind of like in cellular, you guys might be familiar with like LTE, 3G, 5G, right? Each one is a newer technology that's faster, stronger, all that good happy stuff. With wireless, they have 802.11ac, so that's just the name of the IEEE standard, each standard that goes up, but it's not really intuitive in that. I mean, it is in that the higher the letter, the newer the technology, but you basically have A, B, G, N, AC, and then AX is the newest one. So again, it's not like A, B, C, D, E, F, G, right? So there's tons of stuff that happens in between. So that's why when you go to Best Buy and you're looking at it and you're seeing the difference between N and AC, it's not really intuitive which one's better, right? Again, but if you understand that it goes, so when they do these committees, it's 802.11 A through Z, and then they start over AA, AB, AC, A. So that's why it goes back, right? And so maybe in 20 years you'll have the AAX or the AZ, I guess it would be T, whatever it is, right? So they'll just keep adding letters. Right now on campus we are completely 802.11 AC. So every access point supports AC. The trick to keep in mind is that in order for you to be able to operate at AC, which is more or less the latest, the access point has to have that, and your device has to have that, right? It's a laptop maybe? So like right now, all of our access points have AC. So when AC first came out, I remember we had several people complain, oh yeah, I'm not getting, first of all, the box says that this can get 1.3 meg, so, or 1.3 gig, 1300 meg, roughly. So let's say, so they're like, okay, I'm not getting anywhere near that speed, what's going on? So again, we had access points that had AC, but their device still was 802.11n, right? So again, if it's like this, that means your device is gonna talk at the end, right? Because it's not capable of doing AC. The other thing is most of those numbers on the box is, it's just sales numbers that don't actually exist. So this 1.3 is a theoretical access point. The current top speed of this one was 450, and even then it's like if you're right next to the access point with a big giant laptop, and then even then this is your highest data rate, so half that is your top speed with no one else in the room in a vacuum. So again, we right now our service level agreement for people is 5 meg. So if you get over that, you're doing good. 5 meg, you can stream HD YouTube video and surf the net and listen to music all at the same time with 5 meg. So that's another one. So again, capability has to be on the access point side and on the laptop. The only thing I'll say about this, if you hear anyone talking about AX, which is called Wi-Fi 6, so from a branding standpoint, they've decided that they're now going to, rather than using these letters, they're just going to put numbers. So theoretically, the next one, we'll call it Wi-Fi 6. The next one will be Wi-Fi 7, I guess. So I guess that at least makes it a little easier for consumer side. They are making access points at this, but currently right now on the market, there's only one device that has 8X, which is the Note 10, Samsung Note 10. And the rest of this year and next year, you'll start seeing more handheld devices have it. But again, I doubt anyone will ask about it. We are not, we're currently not buying 8x access points yet. We'll probably move to those soon. But built into the standard, whatever the access point is, it has to support everything above it. So even if we get this, everyone behind it is still support. That's probably way more information than you guys need. So this is what actually helps. So beyond all the jargon, so all access points here on campus have 2 radios. So these are just different frequency ranges, 5 and 2.4, so 5 gigahertz and 2.4. So again, think of like spectrum, right? Like your AM, FM radio, and you guys go to different stations. So again, those are different frequency ranges. Think of this one as kind of like your feeder road, and this one is I-10 going west out to Katy. So this one, there's only 3 lanes. This one has a ton of lanes. I think right now we're using about 12, but we can use more than that. So again, the more people that are on 5 gig, the better. So right now we're averaging about 80 to 85%, and then 10 to 15%. But in an ideal world, it would be like 95% of our clients are on 5 gig, 5% are on 2.4. So this can be a huge one, and at the end I'll show you, there actually is a way on your devices to say prefer 5 gig. So in wireless, the client device actually determines what access point it connects to, what frequency it connects to. There's ways we can try to trick it, but ultimately the wireless client is the one that makes that decision. So there's things you can do on the client side. Make sure they have newer devices. So again, that's kind of what we talked about, newer devices, newer technology, and then latest drivers. So, and again, I think I have a slide on that later. Yes. The only thing I'll say about this is TDCU Stadium, currently we don't do the Wi-Fi. So if you guys hear anyone complain about the stadium Wi-Fi, that's actually Boingo, who does like airports and things like that. They actually manage wireless. And they only have it in certain parts of the stadium. So the vast majority of people that attend a game do not have wireless access. Okay. So from our side, these percentages, this is a breakdown of like a typical month, what percentage of issues we've found at different legs. So the reason why I put this on here is because what we hear is Wi-Fi sucks, right? What actually is that every single one of these is a component that delivers all of that service to Wi-Fi, right? So the example I used is for the NCAA tournament. They had a little app, right? So you could surf the app, get all your news and updates, but as soon as you went to stream the game live, it didn't work. So they said Wi-Fi sucks. If I switch to cellular, it works. I switch to Wi-Fi, it doesn't work. What it ended up being was they basically contracted out to what's called a caching server, and that caching server is basically having issues. So again, that's a perfect example where it wasn't actually the RF, it wasn't access switches, distributions, core, wireless, core switches, firewall, any of this stuff. It was literally a caching server out on the internet. But the vast majority of the time when we see issues, it's 60% of the time it's the device itself. So adapters, drivers, people are too far from the access point, whatever it is. 15% of the time it's somewhere between the access point and the RF. So I was telling you guys 2.4 is bad. So microwave ovens work on 2.4. So if you're in like a break room and someone heats up a burrito, Wi-Fi goes away, right? So that microwave oven just blasts extremely loud, extremely wide on that channel, and nothing else happens until it's done. So that's in that 15%. Then 15% might be something, a port configuration, switch issue, controller issue, 4% some weird policy issue, and 5% is out on the internet somewhere. So 60% of all tickets can be resolved just by addressing the device issue. So trying to figure out either helping the user troubleshoot their own device or us helping them do that. The more information, the better. So we have a question, a little questionnaire that the students are supposed to open up about tickets. So each one of those questions is supposed to eliminate a different leg in that process. So again, when people say wireless sucks, that doesn't really help us. We need more information to try to figure out what's going on. I like when people tell me they're having trouble downloading illegal things online. Thank you for that. No feedback makes Shasta sad. Okay, troubleshooting. So the nice thing is on Apple devices, in typical Apple fashion, they don't ask for permission. They just upgrade your drivers, whether you like it or not, and it just happens. In Microsoft, it's the opposite, which is, you know, in the bottom right corner, you'll see the little wireless sign. You can open up your, I don't think I have a picture. Oh, here we go, the network. So sometimes you can say, automatic update drivers, and it'll say, no, your drivers are good on a Windows device. 90% of the time, that's wrong. So I used to have a slide in here where I checked mine, and I did that. It said everything was good, and then I manually went to go check the drivers, and the drivers were like 3 years old, and there was like 15 updates since then, and each one was like, fixes this, you know, this terrible bug that happens, and this one restarts your computer, and this one, you know, whatever it is, right? So the best way that I found to do it is, again, you go to your wireless adapter, and you can pull it from here or go into status, but basically you want the name of your adapter. So this one's a Dell Wireless 1540 802.11. Just put that in Google, end it with drivers, and then the top thing typically that pops up is the whatever the latest drivers are for that adapter, and then just manually installing it. Most of them are going to be Intel drivers. Intel's pretty good about updating their drivers pretty regularly. The other thing is, so from this menu, if you go to configure, so you're clicked on your device, configure. Over here, not all adapters will allow you to do this, but you can see it says band preference. So band means the frequency, basically. So you can say prefer A or prefer G. So A is 5 gig, and then G is 2.4. That's 2.4, but it's not that you're actually going to a lower standard, they're just trying to distinguish between 5 gig and 2.4. And so some people will say 2.4 and 5, others will say A or GBP. So the question I've gotten with this sometimes is, yeah, that optimizes me for on campus, but what about when I go home? So 2 things. One is this just says prefer, so they're actually, sometimes drivers will allow you to force it, so basically say, I don't want you to ever talk on 2.4. Don't do that, because there are some, like, again, you go to McDonald's, sometimes they'll have only 2.4 on the radio, and then all your friends sit there and connect, and you look at it and you won't even see a network available. The second thing is, in a high density environment, ours, so 2.4 does broadcast a little bit further than 5 gig. So like if you're at home and you're trying to get Wi-Fi in your front yard, you might actually you'll have better service on 2.4 than 5. And you don't have the same congestion issues as you will on campus. Because here you just, unless you regularly invite 40,000 people to your house, it's just different density wise. So, but again, if you put prefer on there, if your device sees that 2.4 is obviously better than 5, then it'll just go to 2.4. So that's why we typically will recommend it. So there's 2 tests, I think, that we have in our little recommendation document. So uh.edu/line test. So this actually tests against a server that we have that sits next to our wireless controllers. And then speedtest.net is a great website just generally. So if you're out publicly and you want to see how quick your connection is, speedtest.net is great. Sometimes we'll ask people to run both, because again, let's say you get a uh.edu line test here and the speeds are awesome. Go to speedtest.net and they're terrible. Okay, well now we know up to here is good, but down here there might be an issue. So firewall, something out in the internet, things like that. So again, by having both speed tests, it helps us to do it. Anything on that speedtest.net, we get a report on. So this is what it looks like, all those tests that are run on the back end. We get a nice pretty chart. And again, our SLA is 5. So that's 5.7, 5.4. So there's actually no failing tests on here that I can see. I think maybe that's, I don't know what that is. So, I will say we have to report on this every week. So again, if you have people that are having issues, one way that they can get our attention is having tons of failed tests, and we can see they're having tests in E. colon. So during this report, there's 53 of them done. And on here, they're actually asked what room they're in. So it can help that, oh wow, we have a ton of failed tests from this room, we gotta investigate. Those are our current help desk questions. So again, each one of these helps eliminate part of the leg. So if you can get to UH.edu and not Texas.gov, then there's a internet connectivity issue. If you can't even get to UH.edu, then it's even further up the line. Maybe you can't get past the controller. If you go on here and you have like a 169 address, which is a self-assigned, then you're not even getting an IP address. There's something wrong there. So again, each one of those helps us to eliminate a part of that leg. Last but not least, Wi-Fi calling. So on campus, in the past, we've put little cellular repeaters because people have complained in basements, things like that, that have issues with calling. Those are expensive, cumbersome, hard to maintain. So we're spending all this money on wireless infrastructure, and now all of the major carriers support calling over Wi-Fi. So that's one thing that we recommend if you guys get any complaints on people having bad cellular service. We say, look, our recommendation is Wi-Fi calling. Our system is optimized to use Wi-Fi calling, so that traffic is prioritized. So again, it seems to support it well. We have lots of people that are using it pretty regularly. Stadium, already talked about it. For TIDA, on the other hand, we've designed, and it is awesome. It works really well during the games, and that one is 100% coverage and capacity. So it doesn't matter where you are in the stadium. I think in the bathrooms, the mechanical rooms, they've got Wi-Fi everywhere, and it works pretty well. Multicast, so this is just a protocol, but anything that uses like a Discovery, so Apple TV, the old Apple TVs, Chromecast, anything where you're mirroring your device up to the screen, or even like AirPrint does the same thing. Currently, those are not supported on campus. The reason why is that each one of those devices, every 100 milliseconds, has to broadcast, hey, here I am. Well, you can imagine in the dorms, you have one per bed. There's 1,000 beds in Calhoun Loft. That's 1,000 devices every 100 milliseconds saying, hey, here I am. Basically just takes down the network, right? It's just way too much traffic. So right now we are dropping all that traffic. We're blocking it. We're working with a newer technology that'll help maintain that, but it'll help us implement it without bogging down the network. But again, I say that because if someone says, look, I'm in the dorms and my Apple TV doesn't work or whatever, trying to get that screen mirroring, then you just tell them, look, it's not supported. Your Apple TV plugged in will still do Netflix and Amazon Prime, all of those things. It's not that those don't work, it's that the phone to Apple TV or phone to device issue is the problem. Any questions? Recommended questions? Yes, wireless is magic.
I'm assuming they still update drivers through Device Manager and stuff like that.
Yeah, so that's the best way to do it. So again, when you go in there and try to auto do it, sometimes it works, sometimes it doesn't. Your best bet is to try to find the actual network card, the NIC card name, and then search for it in Google. And again, I found a lot more success with that.
Okay.
And then just manually update it, whatever it is. And again, the rule typically is newer the better. So if even if they're not having issues, if you guys are already in the laptops, you can say, hey, why don't you go ahead and update your driver on the wireless? Because we've seen, again, like even like, I can't remember what model it was, but the new iPads came out, and they were having all kinds of issues when it first came out. And I can't remember if it was like over aggressive roaming or something, whatever it was, but they just wreaked havoc. And then again, new network adapter driver update, and then just completely fixed it. So we see that stuff all the time, where It's just a bad adapter, bad driver set, bad whatever it is, causes lots of chaos, and then within, you know, a few months, the manufacturer fixes it.
Sounds like that.
Exactly, yeah, exactly. And of course, they don't tell anyone, and then everyone makes a big deal, like, okay, yeah, we're working on it. Anything else? No? Alright, thanks guys.
Thank you.
Thank you.
Thank you.